The smoothness of the early universe might be the strongest evidence that the universe has a deeper structure. And that sounds impossible, because when we look at the oldest light in the universe, everything appears almost perfectly uniform. No seams, no twist, no visible structure. So how could that possibly support the idea that space itself has geometry? Because of Möbius cosmology, the beginning must look smooth. This is the Architect Lab, where we build reality from first principles. In the last episode, we crossed an important boundary. We stopped asking whether deeper structure could exist and started asking where reality would reveal it first. Because if the universe has structure, behavior must eventually expose it. But that raises an immediate objection: the cosmic microwave background, the oldest observable signal in the universe, a snapshot of the universe when it was about 380,000 years old. And when we measured it, the entire sky looks almost perfectly smooth. So the question becomes, why doesn't the beginning reveal the structure? Because structure does not reveal itself instantly, it reveals itself through accumulation. Structure influences behavior, but behavior must compound before influence becomes visible. Imagine dropping a single grain of sand into a mountain slope. Nothing dramatic happens. But if you repeat that process billions of times, the entire landscape begins to move. The structure of the terrain was always there, but the motion revealing it had to accumulate. The universe works the same way. If spacetime has a deeper geometry, its influence cannot appear immediately. It must build, through motion, through curvature, through billions of years of cosmic evolution. And this is exactly what my theory Möbius cosmology predicts. In Mobius cosmology, the geometry of spacetime is globally non-orientable, which means the structure of the universe cannot reveal itself instantly. It must appear through accumulated behavior, through motion, through curvature, through large-scale structure evolving over billions of years. So the earliest observable signal in the universe should almost look perfectly uniform. And that's exactly what we see. Alright, let's pause. What has to be true? If the universe has a deeper structure, the earliest signals must appear smooth, because there hasn't been enough time for structure to influence behavior. Those deviations cannot appear first in the beginning. They must appear later, where motion compounds, where curvature accumulates, where billions of years of cosmic behavior begin to expose the structure underneath. And that flips the entire expectation. The smoothness of the early universe is not evidence against deeper structure. It's exactly what deeper structure predicts. The beginning must look smooth, the deviations must appear later, and the accumulated structure of the universe, and that tells us something incredibly important. It tells us where to look. I want you to think about how water creates a canyon. No single drop of water creates it, but over millions of years, flowing water slowly exposes the shape of the land. The terrain was always guiding the river, but you only see the results after enough time has passed. The early universe is the untouched landscape. The structure reveals itself later, through accumulated motion. In a universe with deeper structure, the earliest signals must appear smooth, because the structure reveals itself only through accumulated behavior. And that means the real test of the universe is not in the beginning. It's in what happens later, where motion compounds, where curvature accumulates, where the structure of space-time can no longer remain hidden. So if the beginning looks smooth, where does the structure actually appear? My name is Eric Mize, and this is the Architect Lab. Welcome to reality.